Okay, so today we're going to be covering section 10.3, which is on polygons. We've got four main objectives. Today we're going to be looking at how do we name certain polygons, recognize the characteristics of certain quadrilaterals, and then also solve some problems involving perimeter and finding the measure of polygons' angles. Okay, so when you are naming polygons, we typically name polygons by the number of sides that they have. We can see here that a three-sided polygon, our triangle, is right here. And then as we go up, our quadrilaterals, that's the name for four-sided polygon, pentagon, 5 sides, hexagon, 6 sides, our heptagon, 7, octagon, 8 sides. You'll notice that these are names of regular polygons. What it means by regular polygon is that all sides are the same length. A type of polygon that is studied regularly is quadrilaterals. There are some special names for quadrilaterals so that when we talk about them, we know the properties that they have. A special type of quadrilateral is a parallelogram. You can see the characteristics here that we have opposite sides that are parallel. Our opposite sides are also congruent. This also means that our opposite angles are congruent. The markings on the diagram here show that. Our hash marks show congruent sides and congruent angles. A rhombus is a special type of parallelogram. What makes a rhombus special is that all sides are congruent. Our rectangle has 4 right angles. It also has the same properties of a parallelogram, where our opposite sides are parallel and also congruent. Our square, very special little polygon. It's got 4 congruent sides and 4 right angles. Trapezoids. The condition that makes a trapezoid is that it has exactly 1 pair of parallel sides. You can see here that our bases are parallel to each other. When we're talking about perimeter is the distance around an object. So to find perimeter of any polygon, you would add up the length of the sides. Here we have a rectangle. And so this rectangle, since we have 2 congruent sides and then another pair of congruent sides, when we write the formula, we have our perimeter is equal, and we have W plus L plus W plus L. So our lengths and widths added together. Now we can simplify this formula since we have our widths are the same, 2W plus 2L. You can always find the perimeter of any polygon just by adding up all of the sides. All right, so let's do an example here where we are working with perimeter. We have a rectangular field that was discussed at the beginning of the section. It has a length of 42 yards and a width of 28 yards. If fencing costs $5.25 per foot, we want to find the cost to enclose the field. Well, we've got our 2 widths, which are 28, and we have our lengths, which are 42. So first I want to find the perimeter of this field. If I add that together, since it's a rectangle, I know that my widths are the same and my lengths are the same, so I can set it up using that perimeter formula I just came up with. If I evaluate this out, 2 times 28 is my 56, 2 times 42 is 84, and I'll find that the perimeter of this field is 104 yards. Now it's important that I think about my units here. This is 104 yards, and the cost of my fencing is given per foot. So I want to know how many yards or how many feet are in 104 yards. If I take 104 and multiply it by 3, since there are 3 feet in each yard, I'll find that there is a total of 420 feet. I think my math is wrong here because that's not making sense with what I have. Let's pause this. Yeah. All right, so let's take a look at an example as an application of perimeter for looking at a rectangular field that has a length of 42 yards and a width of 28 yards, and fencing costs $5.25 per foot. We want to know the cost to enclose the field with fencing. Since this is a rectangle, I know that my 2 sides opposite each other are congruent. So it has a width of 42 and a length here. If I want to find the perimeter, I'm going to add up all of my sides. We've got 2 sides that are 28 yards and 2 that are 42 yards. 2 times 28 is 56, plus 2 times 42, which is 84. That gives me a total perimeter of 140 yards. Now, since the cost of my fencing is given per foot, I'm going to want to have convert my 140 yards. How many feet is that? Well, there are 3 feet in each yard. So if I take 140 times 3, then that's going to give me 420 feet. Each of those feet cost me a total of $5.25. So then the total cost to fence this in would be $2,205. All right, so we've talked about side lengths of a polygon. We can also talk about the measure of the angles. It's sometimes helpful to know what the angles add up to. If you take some polygons and divide it up into triangles, you can see that you can always break it up into a certain number of triangles. That gives us our formula for finding the sum of the measures of the angles in a polygon. The number of triangles formed will always be our number of sides minus 2. Since there are 180 degrees in each triangle, we get our formula that the sum of the measures of the angles of a polygon with n sides is n minus 2 times 180. Okay, so let's do some examples with where now we apply that formula that we saw. We've got an octagon here, which is our 8-sided figure. We want to find the sum of the measures of the angles of an octagon. So we know that an octagon has 8 sides, so our n equals 8. If I want to know the measure of the angles, plugging in 8 for my number of sides. And so we get 6 times 180, which tells me that there are 1,080 degrees in those interior angles. So all of these angles here on the inside add up to 1,080 degrees. All right, so we found in part A that there is 1,080 degrees in all of those angles inside my polygon, my octagon here. And so let's take a look at part B. We want to find the measure of angle A, so just one of those 8 angles. Since this is a regular polygon, we know all of our angles have the same measure. So if I want to find my measure of angle A, well, I can take that 1,080 degrees and I can split it evenly over those 8 sides. That's going to give me the measure of one of those angles to be 135 degrees. All right, so now that we have found the measure of that angle A, We want to know the measure of angle B, that exterior angle that lies on the outside of the polygon. Well, I know that this forms a straight line here. So if there are 180 degrees in a straight line, I know that my angle A, which is 135, plus my angle B must add up to 180. Solving that out, I'll find that the measure of that exterior angle B is 45 degrees. If I wanted to find the measure of all of those exterior angles, just like there's 8 interior, there's a total of 8 exterior angles. And so if I found the measure of all my exterior angles, I'd have to take that 45 degrees times 8, which you'd find is 360 degrees. An interesting property of exterior angles is that the exterior angles of any polygon will always add up to 360 degrees. And that is 10.3. Now you know a lot more about polygons.